ISRO originally intended to launch MOM with its Geosynchronous Satellite Launch Vehicle GSLV, but the GSLV failed twice in 2010 and still had issues with its cryogenic engine. Waiting for the new batch of rockets would have delayed the MOM for at least 3 years. So ISRO opted to switch to the less powerful Polar Satellite Launch Vehicle PSLV, since it was not powerful enough to place MOM on a direct-to-Mars strategy. The spacecraft was launched into a highly elliptical Earth orbit and used its own thrusters over multiple Apogee burns to take advantages of the orbit effect to place itself on a trans-Mars strategy. On 19th October 2013, ISRO Chairman K. Radhakrishna announced that the launch had been postponed by a week for 5th November 2013 due to a delay of crucial telemetry ship reaching Fiji. The launch was rescheduled. ISRO's PSLV-XL placed the satellite into Earth orbit on 5th November 2013 with a Apogee of 261.1 km, an Apogee of 23,903.6 km, an inclination of 19.20 degrees. Both the antenna and all the 3 sections of the solar panel arrays deployed, used on India's communication satellites. Its main engine, a derivative of the system, uses the bipropellant combination of monomethyl hydrazine and dinitrogen tetroxide to achieve the thrusters necessary for escape velocity from Earth. It was also used to slow down the probe for Mars orbit insertion and subsequently for orbit corrections. Orbit raising maneuvers. Several orbit raising operations were conducted from the Spacecraft Control Center (SCC) at the ISRO Telemetry Tracking and Command Network (ISTRAC) at Peenya, Bengaluru on 6th, 7th, 8th, 10th, 12th and 16th November by using the spacecraft onboard propulsion system and a series of Apogee burns. The first 3 of the 5 planned orbit raising maneuvers were completed with nominal results, while the 4th was only partially successful. However, a subsequent supplementary maneuver raised the orbit to intended altitude aimed for in the original 4th maneuver. A total of 6 burns were completed with the spacecraft remained in the Earth orbit, with a 7th burn conducted on 30 November to insert MOM into a heliocentric orbit for its trans to Mars. Now let's see the orbit raising. The first orbit raising maneuver was performed on 6 November 2013 when the spacecraft's 440 Newton liquid engine was fired for 416 seconds. With this engine firing, the spacecraft Apogee was raised to 28,825 km with a Apogee of 252 km. The second orbit raising maneuver was performed on 7th November 2013 with a burn time of 570.6 seconds, resulting in an Apogee of 40,186 km. The third orbit raising maneuver was performed on 8th November 2013 with a burn time of 707 seconds, resulting in an Apogee of 71,636 km. The fourth orbit raising maneuver starting on 10th November 2013, but here we faced a big problem. Listen carefully. Imparted a delta V of 35 meter per second to the spacecraft instead of planned 135 meter per second as a result of underburn by the motor. Because of this, the Apogee was boosted to 78,276 kilometers instead of planned 1 lakh kilometers. When testing the redundancy built in for the propulsion system, the flow of the liquid engine stopped, with consequent reduction in incremental velocity. During the fourth orbit burn, the primary and reductant coils of the solenoid flow control valve of 440 liquid engine and logic for thruster augmented by the attitude control thrusters were being tested. When the both primary and redundant coils were energized together during the planed modes, operating the both coils simultaneously is not possible for future operations. However, they could be operated independently of each other in sequence. As a result of the fourth planet burn coming up short, an additional unscheduled burn was performed on 12th November 2013 that increased the Apogee to 1,18,642 km, a slightly higher altitude than originally intended in the fourth maneuver. The Apogee was raised to 1,92,874 km on 15th November 2013 in the final orbit raising maneuver. Trans-Mars injection. On 30 November 2013, eminent engine firing initiated the transfer of MOM away from the Earth orbit on heliocentric orbit towards Mars. Now the spacecraft was completely in deep sleep. The probe traveled a distance of 78 crores kilometers to reach Mars. While entering into Mars orbit, we have to decrease the probe speed, or if we miss the Mars orbit. Now it's time to wake up. It's like waking up Kumbhakarna after a long deep sleep. Successfully, the spacecraft engine was ignited. After these events, the spacecraft performed a reverse maneuver to orient from its deceleration burn and entered Martian orbit. This is the great successful to our India nation. This is one of the great success to India. Status. The orbit insertion put MOM in a highly elliptical orbit around Mars as planned with a period of 72 hours 51 minutes 51 seconds, a periapsis of 421.7 kilometers, and apophysis of 76,993.6 kilometers. At the end of the orbit insertion, MOM was left with 40 kg of fuel on board, more than the 20 kg necessary for a 6 months mission. On 28 September 2014, MOM controllers published the spacecraft's first global view of Mars. The image was captured by the Mars Color Camera (MCC). On 7th October 2014, the ISRO altered MOM's orbit so as to move it behind for Comet Sliding Springs flyby of the planet 19th October 2014. The spacecraft consumed 1.9 kg of fuel. As a result, MOM apogee was reduced to 72,000 kilometers. After the comet passed by Mars, ISRO reported the MOM remains healthy. On 4th March 2015, the ISRO reported that the MSM instrument was functioning normally and are studying Mars albedo, the reflectivity of the planet's surface. The Mars Color Camera was also returning new images of the Martian surface. On 24th March 2015, MOM completed its initial 6 months mission in orbit around Mars. ISRO extended the mission by an additional 6 months. The spacecraft has 37 kilograms, 82 lb of propellant, and all 5 of its scientific instruments are working properly. The orbit can reportedly continue orbiting Mars for several years with its remaining propellant. On 24th September 2015, ISRO released its Mars Atlas, a 120-page scientific atlas containing images, data from the Mars orbiter mission's first year in orbit. In March 2016, the first science results of the mission were published in Geophysical Research Letters, presenting instrument operated by the spacecraft MENCA instrument of the Martian exosphere. During 18 to 30 May 2016, a communication whiteout occurred with Mars, Earth coming directly between the Sun and Mars. Due to high solar radiation, sending commands to spacecraft was avoided and payload operations were suspended. On 17th January 2017, Mom orbit was altered to avoid the impending eclipse season with a burn of 822 Newton thruster for 431 seconds, resulting in a velocity difference of 97.5 meter per second, 351 km per hour, 44 lb of propellant, leaving 13 kgs remaining. Eclipse were avoided until September 2017. The battery is able to handle eclipse up to 100 minutes. On 19th May 2017, Mom reached 100 days 973 souls in orbit around Mars. In that time, the spacecraft completed 388 orbits of the planet and relayed more than 715 images back to Earth. On 24th September 2018, Mom completed 4 years in its orbit around Mars. Although the design mission life was only 6 months. Over these years, Mom's Mars color camera has captured over 980 images that were released to the public. The probe is still in good health and continues to work normally. On 24 September 2019, Mom completed 5 years in orbit around Mars, sending 2 terabytes of imaging data and had enough its propellant complete another year in orbit. This was so great to listen. In 2014, China referred to India's successful Mars orbiter mission as the Pride of Asia. The Mars orbiter mission team won US-based Space Pioneer Award in the Science and Engineering category. NSS, the award was given as the Indian agency successfully executed a Mars mission in the first attempt, and the spacecraft is in an elliptical orbit with a high Apogee where with its high-resolution camera. It is taking full disc color imagery of Mars have ever been taken in the past, mostly on approach to the planet, as the most imaging is done looking straight down in a mapping mode. An illustration of the Mars orbiter mission spacecraft is featured on the reverse of the 2000 currency note of India. An image taken by a Mars orbiter mission spacecraft was cover photo of the November 2016 issue of National Geographic magazine for the story of Race to the Red Planet. This complete credit goes to our ISRO team. K. Radhakrishnan, Chairman ISRO. Mailswamy Annadurayan was the Program Director and in charge of budget management as well as the Director for spacecraft configuration. S. Ramakrishna was a director who helped in developing the liquid propulsion system of the PSLV launcher. P. Kunnikrishnan was a project director in the PSLV program. He was also a mission director of PSLV C-25 or Mars Orbiter mission. Momita Dutta was a project manager of the Mars Orbiter mission. Nandini Harinath was a deputy operations director of navigation. A.S. Kiran Kumar was the director of the Satellite Application Center. S.K. Shivakumar was a director at the ISRO Satellite Center. He was also project director for the Indian Deep Space Network. Subbaiah Arunan was a project director at Mars Orbiter mission. B. Jayakumar was an associate project director at the PSLV program who was responsible for testing the rocket's systems.